How do you size overcurrent devices using interrupting rating? Imagine a lightning bolt striking a power line and causing a sudden surge of current. How do your protective devices handle such a powerful event without failing? That's where the concept of interrupting rating comes into play. It's a key factor in making sure your electrical system stays safe and reliable. When designing or maintaining power systems, especially in renewable energy setups or complex power distribution networks, understanding how to size overcurrent devices using their interrupting ratings is essential. The interrupting rating of an overcurrent device tells you the maximum fault current it can safely stop without breaking apart or causing further damage. Think of it as the device's safety limit. If a fault causes current to spike beyond that limit, the device might fail, which could lead to equipment damage, fires, or safety hazards. That's why selecting a device with an appropriate interrupting rating is so important. To size these devices properly, you first need to figure out the highest possible short-circuit current at the location where the device will be installed. This involves looking at system data, transformer ratings, conductor sizes, and impedance values. For example, if your system's maximum fault current at a certain panel is calculated to be 65,000 amperes, then the circuit breaker or fuse you choose must have an interrupting rating of at least 65,000 amperes. Modern circuit breakers and fuses often have high interrupting ratings, sometimes reaching 100,000 amperes or more. This makes them suitable for most industrial and commercial applications, including renewable energy systems like solar photovoltaic installations. In these systems, inverter characteristics and system configuration can influence fault current levels, but the same sizing principles apply. It's also important to use devices specifically designed for overcurrent protection. Contactors and switches, for example, are not meant to interrupt fault currents and should not be used for this purpose. Only devices like fuses and circuit breakers with the right interrupting ratings should be installed for safety. In renewable energy systems, knowing the available fault current at each point helps you select the right protective devices. For instance, if a solar inverter can produce a fault current of 50,000 amperes, your overcurrent device must have an interrupting rating of at least that amount. This ensures the device can clear faults quickly and safely. Properly sizing overcurrent devices using their interrupting ratings keeps your system safe, prevents damage, and makes sure you stay compliant with electrical codes. It's a fundamental step in designing reliable power distribution systems, especially when dealing with high fault currents that can occur in complex setups. Always remember, selecting the right device for the job means your system can handle the worst-case fault scenario without risking safety or equipment integrity.